Hello, this is Mr. Spy, and this will be my second video on Algebra 2, Unit 1, on evaluating a function. Let's begin. Okay. So in day 2, we cover function notation and evaluating functions. So in function notation, instead of writing y equals 3x plus 5, you write y would be f of x equals 3x plus 5, or f at x. So the way you read this is f, parentheses x, you'll either read it as f of x or f at x. I prefer the second way of reading it because it doesn't confuse people in multiplication. So here's a few examples of writing different equations in function notation. So y equals 3x plus 5 is written as f of x equals 3x plus 5. Y equals the square root of 2x plus 6 will be written as f of x equals the square root of 2x plus 6. And if you notice in the third example, y equals 2 to the p, instead of using f at p, meaning f at x, we use f at p of 2 to the p. Now we don't have to use f. We can use G, H, any letter, but the most commonly used letters are F, G, and H. Let's go on to the next slide. Okay, now that's how you do things in function notation, really basic. Now once you have function notation, you could substitute values in for x. So given f of x equals 2x minus 6, we use the substitution property and we substitute in the number for x. So for the first example, we replace, we have f at 3. So wherever we have an x, we place 3 and we simplify. So 2 times 3 is 6. 6 take away 6 is 0. Now you do f at negative 4. 2 times negative 4 is minus 6. Negative 8 minus 6 is negative 14. You even could plug in an expression like 2a. 2 times 2a minus 6 multiplied by 2. 2 times 2a is 4a minus 6. So you can plug in or substitute in a number or a term. So some more practice. So let's say we had g of x equals 3x squared minus 5x. Find g at 3. So g at 3 be 3 times 3 to the second minus 5 times 3. Follow the order of operations. That's 3 times 9 minus 5 times 3, which is 27. Take away 15, which is 27 take away 15. 12. Okay, now let's try the next one. Instead of x, so we have h of x equals 3x to the 5th. So we find h at negative 4. So that would be 3 negative 4 to the 5th power. So you first do the exponent, negative 4 to the 5th power. 4 raised to the 5th power, so 4 to the 5th power. I think it's 1280. Just double check. 1024. 4 to the 5th power is 1024. So 3 times negative 1024 times that by 3 is 3072. Just remember, even powers when negative is positive. Odd powers when negative is negative. So in this case, you have an odd power. Our answer is negative. Here we have an even number. Our answer is positive. So we have negative 2 to the 6th power. 2 raised to the 6th power is 64. So this will be 5 times negative 2 to the 6th power, which is 5 times 64, which is a total of 320. Take a minute to copy anything you need down, and we'll go on. Okay, let's continue. Let's do a bit of a more challenging function. Here we have a square root function. So V, capital V, very careful, lowercase and lowercase and capital letters do mean different functions. Usually capital letters are used for functions used in science or business, and lowercase letters are used for a general function. So here we have V at 0 equals the absolute value of 2 times 0 minus 8 plus 1. 2 times 0 is 0, the absolute value of negative 8 plus 1, which is the absolute value of negative 8 is 8, because absolute value always makes it positive. 8 plus 1 equals 9. So the answer here is V at 0 equals 9. A good way to write your answer. Here we have Q of x equals the square root of 2x minus 2. So the Q at 8 is the square root of 2 times 8 minus 1. Square root of 2 times 8 is the square root of 16 minus 1. The square root of 16 is 4. 4 minus 1 is 3. So Q at 8 is 3. Take a minute to copy anything down. And we'll go on to the next slide. Okay, a bit more challenging functions. Here we got T at R, which is a polynomial function. I happen to use a capital letter. So R at 4 is 5 times 4 to the 4th power minus 2 times 4 to the 3rd power plus 12 divided by 4 minus 2. And you notice that every single place, that there is an R, I plugged in the value 4. And you got to do it in every single place. So you do this slowly. 4 raised to the 4th power is 256. So 5 times 256 minus 2 times 64 plus 12 divided by 4 minus 2. Keep on simplifying. 5 times 256 is 1280 minus 128 plus 3 minus 2. So 128 minus 1280 minus 128 plus 3 minus 2. It's a total of 1,153 for R at 4. Now, sometimes I can ask you to substitute in an expression. So given h of d equals 2d plus 5, here they're asking you to find h of d plus 8, or h at d plus 8. So in this case, we're going to emphasize you're plugging in d plus 8 for d. So that becomes 2 times d plus 8 plus 5. Then to simplify, you distribute the 2. Get 2d plus 16 plus 5, which is 2d plus 21. You could theoretically leave your answer like this. The way I'm highlighting it. But most teachers and students prefer to simplify. Take a minute to copy anything down, and we'll go on to the next slide. Okay, so that's how you evaluate a function. In the next function, I'll go on to my day 3 lesson, going over domain and range of discrete functions, what is the difference between discrete and continuous functions. I'm also going to mention domain and range of continuous functions that are over a defined interval. Hope this was helpful and hope this was enjoyable. I hope to see you next time on my day 3 video, which will hopefully be posted on Monday. This is Mr. Spicer, also known as Mr. Spy, signing off. Have a great day. Please subscribe to my channel, hit the bell for alerts about more videos. Hoping to post 4 videos a week. This is my second video. Have a great day and have a great weekend. Bye, everybody.